We will now begin section 2.4, where we will discuss parallel lines. Let's start with the definition. Two lines with slopes m sub 1 and m sub 2 are parallel if and only if m sub 1 is equal to m of 2. What this tells us is that lines are parallel if their slopes are equal. So I'm going to just make a note here that parallel lines have equal slopes. Let's look at an example. Our example says, find equations for two lines parallel to each of the lines given below. Part A has the equation y is equal to negative 2/3 x plus 4. So let's begin with part A. What you want to keep in mind is that part A is written in slope-intercept form. Recall that slope-intercept form looks like y is equal to mx plus b, where m is your slope and b is your y-intercept. So if we look at our equation, y is equal to negative 2/3 x plus 4, we see that the slope sits in front of the x. And so I know that my slope is going to be negative 2/3. So if I want to write an equation for a line that is parallel to that, I want to keep in mind that that line should have an equal slope. So my answer should start off y is equal to negative 2/3 x plus, and in order for it to be a different line, it will need to have a different y-intercept. And here you can really choose any value that you want. So there are lots of different answers to this question. I could pick maybe the number 5. And then I therefore have an equation of a line that is parallel to the first line that we were given. So again, we want our new line to have the same slope and a different y-intercept, and it will be parallel. All right, let's consider part B. Now part B is a little more difficult because the equation is 10x minus 2y is equal to 14. And this equation is not in slope-intercept form, but we can get it there. So let's do that first. Let's solve this equation for y. So I'm going to begin by subtracting the 10x off of both sides. So when I do that, I'm going to be left with negative 2y on the left is equal to 14 minus 10x on the right. Then I'm going to divide both sides by negative 2. And remember that when I divide this by negative 2, essentially I'm dividing each of these terms by negative 2. Which gives me an equation, y is equal to negative 7. The negative 10 over the negative 2 becomes a positive 5x. And all I'm going to do here is just rearrange the order here so that it looks like what it's supposed to. I'm going to say y is equal to 5x minus 7. Now, this is the equation of the problem that we were given. Now our job is to write an equation that is parallel to that one. Well, what is the slope in this equation? We know that in mx plus b form, the slope sits in front of the x. So our slope is 5. So in our answer, y is equal to, we need to have the same slope, 5x, and we need to have a different y-intercept. So instead of minus 7, we could pick a different number, like maybe minus 3. And then we will have an equation of a line that is parallel to the given problem. Another type of example that you might see might say, find the equation in slope-intercept form for the line which is parallel to the line 3x plus 5y is equal to 23 and passes through the point negative 2, 1. So let's take our given line, 3x plus 5y is equal to 23. And let's gather information about that line. Specifically, I would like to know, what is the slope of this line? Now I know that if I'm going to find the slope, it needs to be written in slope-intercept form. So let's begin by working on that. Slope-intercept form, remember, means that you're going to solve it for y. So I'm going to subtract the 3x from both sides, which will leave me 5x is equal to 23 minus 3x. And then I'm going to divide everything, or both sides, by the 5. Remember, dividing on the right by 5 means we're going to divide both of those terms by 5. So our equation becomes y is equal to 23 over 5 minus 3x over 5. And I'm going to rearrange the order again just so that it's in the right format. So I'm going to say y is equal to, I'm going to put this negative 3x over 5 first. And then I'm going to put the 23 over 5 next. Okay, so our question was, what is the slope of this line? And remember that in y-intercept, in slope-intercept form, the slope will sit in front of the x. And so here is my slope. So I know that the slope of this line is negative 3/5. All right, so let's talk now about our new line. Our new line that we're looking for the equation of has to be parallel to the original line. So what do we know about our new line? We know that if it's going to be parallel to this line, that it has to have the same slope. So we know that the slope of the new line is negative 3/5 as well. We also know that our new line is going to pass through the point negative 2, 1. So it contains negative 2, 1. So do we have a way to write an equation of a line if we have the slope and we have a point on that line? And in the last section, we learned about the point-slope form of the equation. So remember that point-slope form looks like y minus y1 equals the slope m times, in parentheses, x minus x1. And remember that your point that you had would fill in for the x1 and the y1. So we actually have exactly what we need to write the equation. So let's plug in. In place of the y1, I'm going to put the 1. In place of the slope, I'm going to put the negative 3/5. And in place of the x1, I'm going to put the negative 2. All right, so we end up with, just simplifying just a little bit, y minus 1 is equal to negative 3/5, and in parentheses, x plus 2. That subtraction and that negative make a plus. Now, we're done, except that we don't have the equation in the right format. So the problem asked me to put it in slope-intercept form, which means that I need to solve it for y and simplify. So I'm going to go ahead and add this 1 to both sides. All right, and I'm going to make myself a little bit of room here. Let's get rid of this over here. All right, so I'm going to come over here with this. And so now I have y is equal to negative 3/5 times the quantity x plus 2 plus 1. And to simplify, all we need to do now is to distribute that negative 3/5 through the parenthesis, multiplying it by both of those terms. So y equals negative 3/5 x minus 3 times 2 is 6. 5 times the 1 that sits underneath that is 5 plus 1. And when we combine these two, remember that you could take this 1 and write it as 5/5 so that it has the same denominator as the fraction that you're trying to combine. And so our final answer would end up to being negative 3/5 x. Negative 6 plus 5 is negative 1/5. And so the equation that's parallel and passes through the given point is y is equal to negative 3/5 x minus 1/5. Okay, our last example for parallel lines is a little different. It gives us a quadrilateral, which is a four-sided figure, and it tells us that we want to determine if this is a, well, actually asks us to find if it's a quadrilateral, determine if the quadrilateral is a parallelogram. And so in order for it to be a parallelogram, we have to have both pairs of opposite sides parallel. So let's look at working this out. And so we have a note just to remind ourselves that it is a parallelogram if the left and right sides are parallel and if the top and bottom sides are parallel. So how are we going to check to see if two lines are parallel? Let's begin with the left and right sides. So how do we know if those two lines are parallel? We're going to check the slope. And if the slope of the two lines are equal, then it's parallel. So let's take our points. Let's determine the coordinates of our points. So this point right here is the point -1, -2, -3, -4. And the y value is 2. And this point is -3. And the y value is 4. This point is the point 1, 1. And that point is the point 2, 3. So remember how you find your slope. You are going to look at the difference in the y's. So y2 minus y1 divided by x2 minus x1. And let's be careful here. Let's go ahead and label these things. We're going to work on the left side first. So let's let this be x1 and y1. And our -4, 2 will be x2 and y2. And so let's plug in. So y2 would be a 2. y1 would be a 4. x2 would be a -4. x1 would be a -3. So simplifying here, we would have 2 minus 4, which is -2. And on the bottom, -4 minus -3 would be a -1. And so our slopes would be 2. All right, so let's check this other side. And again, let's label these points. So we'll let this be x1, y1 and x2, y2 for the 1, 1. And let's plug into our slope formula for that one. So for y2, I'm going to put a 1. For y1, I'm going to put a 3. For x2, I'm going to put a 1. For x1, I'm going to put a 2. 1 minus 3 is -2. 1 minus 2 is -1. And again, our slope is 2. So these have equal slopes. So those two lines are parallel. Now we need to do the same thing for the top and the bottom. So let me clean this up just a little bit here. All right, so now we're going to look at this top line right here and the bottom line right here. And we're going to do the same thing in terms of finding our slope. So let's look at the top first. Let's label our points. First point will be x1, y1. Second point will be x2, y2. Let's plug into our slope formula. So for the y2, I'm going to put in a 3. For the y1, I'm going to put in a 4. For the x2, I'm going to put in a 2. For the x1, I'm going to put in a negative 3. 3 minus 4 is negative 1. 2 minus a negative 3 is 5. So the slope of the top line is negative 1/5. All right, let's do the bottom line. So we'll label our first point x1, y1, second point x2, y2. Plug into our formula one more time. So for the y2, I'm going to put in a 1. For the y1, I'll put in a 2. For the x2, I'm going to put in a 1. For the x1, I'm going to put in a negative 4. 1 minus 2 is negative 1. 1 minus a negative 4 is 5. So again, we have equal slopes, so these lines are parallel. And so if the top and the bottom are parallel and the left and the right are parallel, then the figure is a parallelogram.